Hey guys, welcome back to another video. In today's video, we are going to be having a look at the October-November 2020 paper 1, and this was done in 2020 as I told you before. This is variant 1, paper 1, code 0478. So further ado, let's get into this. Okay, so let's begin. So question 1 talks about input, output, and storage devices. So we simply just have to tick whether it's an input, an output, or a storage device. This is quite basic. So here you can see a keyboard. Basically, input is when input. Let me just erase that. So basically, input is when you enter data into the computer. Output is when it displays data. Storage is when it stores data. As simple as that. So let's see a keyboard. You have to input data. So you input data into the computer. A sensor will take input and then will tell the microprocessor to do the stuff. So it is an input. A 3D cutter is making something, therefore it is an output. A 2D scanner, it is scanning something, so it is inputting. A microphone is taking an input of your voice, and an HDD is storage. We know the storage types. We have the HDD, the SSD, the optical storages. We have like the RAM, the ROM, so on and so forth. Those are the storages, and we have talked about this in my previous videos when we talk about the whole syllabus. Okay, the next question is telling us that Ron is attending a music concert and he's buying 3 tickets. Okay, he's buying 3 tickets, and it says that each ticket is displayed as a hexadecimal number. It says complete the table to show the 12-bit binary value and the denary value for each of the hexadecimal. So we're supposed to convert this hexadecimal into a 12-bit binary and then into a denary. So quite simple. The first one is 0 to 8. So what I do, okay, you have to make it a 12-bit, remember, so meaning there should be 12 bits. Okay, so you add a 0 right here, but it's not a must actually, but you can add it if you want. So to convert hexadecimal to binary, you do 8 to 0, separate them into 4 parts, then 1, 2, 4, 8. Basically, this is my method. If you don't understand this method, go and watch the videos. I'll put it down in the description. I've also done an entire video covering the entire syllabus. So if you don't understand on how to convert this, my advice is first go and check that out, because you might not understand what I'm doing right now. So basically, in just a reminder, if you've already watched that video and you don't want to watch it again, the reminder is that you have to simply separate the digits into how many parts it is. So here we have 3 digits, so I'm going to separate it, and then I have to make 8 in binary values. So we use this simple structure 1, 2, 4, 8 to construct it. So it'll be 0, 0, 0, 1, right? Because we want that 8 here. So that's there. And then to make 2, okay, to make 2 I will do 0, 1, 0, 0, which will be here, remember. And then the last one 0, 0, 0, 0. Is this 12 bits? No, this is how many bits is this? This is 12 bits, right? Yeah, this is 12 bits. So we basically just have to write 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0. That is your value, and you can confirm if they're 12 bits. 4 plus 4 plus 4. 4 times 3 is 12, so it should be correct. Okay, so the main idea to convert hexadecimal, you just need to remember this structure 1, 2, 4, 8, and then if it's 0 you don't count it, if it's 1 you count it. So it's as simple as that. The next one is 1A9. We'll convert the denaries later. So 1A9, okay, 1A9, so we need 9, so we can just do 1, 0, 0, 1. We need A is 10 in hexadecimal, so that's 0, 1, 0, 1. Remember, all I'm just doing is 1, 2, 4, 8. 1, 2, 4, 8. And everywhere I put 1, it simply means I'm adding it. Okay, that's what it means to convert from hexadecimal to binary. So wherever there is 1, as you can see here, it means below the value it's 8. So 8 plus 2 is 8, which is 10. Okay, that's what it means. So that's done. And the last one is 1, so it just becomes 1 here, 0, 0, 0. So the hexadecimal is 0, 0, 0, 1, 1010 1001. Okay, just like that. Finally, the next one is 2OC, right? Okay, so we have 2OC converted to 3 parts. 1, 2, 4, 8. C is basically, we know that A is 10, B is 11, so C will be 12. So we need to make 12 from these 4 numbers. So we can just do 1, 1, 0, 0. So 8 plus 4 is 12. So to find 2, and then the next one, 1, 2, 4, 8, this will be 0, 0, 0, because it's 0. So you don't have to add anything. And then to make 2, you just do 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1, 0. Now everyone has their own methods. This is just a method that I prefer. Again, if you don't understand, I will keep reminding you. You might not just understand by me doing this, because sometimes it can be a bit complicated, because I am rushing right now. So I advise you to go watch that video. Now, how can I convert this binary value into denary? So for example, I have this. Okay, I'm basically just writing my binary value, and I'm supposed to convert this to denary. So you just have to do 1, 2, 4, 8, 16, 32. Okay, you can remember the order. Here I have to add, here I have to add, here will be 40, because wherever there's 1 I have to add it. Okay, the next one, let's move on to the next one. The next one is 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1. This one might be a bit long. 1, 2, 4, 8, 16, 32, 64, 128, and 256. So I have to do 256 plus 128, which will be, how much will this be? 384. So 384 plus, now we do 32, which will be 6, 11, 416. Then 416 plus 8 will be 424, plus 1 will be 425. So the answer is 425. All I'm doing is just adding the values where there is 1 on top. So wherever there is 1 here, I'm just adding the value on top. Simply what I'm doing. And you're not allowed calculators, that's why I'm doing this long stuff, long division. That's why I'm doing that. Okay, the next one is 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0. Again, this will be a large number. I don't know why they give you such large numbers without a calculator, but I guess it's 6 marks, so that's why probably 128, 256, and this should be 512, I think. Yeah, it should be 512. So you just do 512 plus 8, which is 520, plus 5, which is 525, 524. So because you're doing plus 13, right? Yeah, so it should be 524. Is it actually? Wait 1 second. 256 times 2 is basically 12, 10, 11, and 512. Okay, it's 512. So 512 plus 12. Yeah, so it's 524. So the answer is 524. 6 marks there. Quite a lot of calculations, but hopefully it's easy. Now, the next question is a question where you have to explain a lot. So this should be a lot of marks, 7 marks. It's telling us each ticket has a QR code. Okay, you need to know QR code, quick response code. And the quick response code is scanned at the entrance to the venue. A person can only enter the venue with a valid QR code that allows entry. When a person enters, the count is incremented to show how many people have entered the venue. Explain how the system scans the QR code, checks if a person can enter, and count how many people. So this is more of a like a logical type of answer. Okay, you have to think. You can't just give out your answers. First of all, you need to understand what a QR code is. You need to know how the QR code works. Okay, so 7 marks, meaning I need 7 points. That's a simple way to understand how these marks are allocated. If it's 7 marks, you need 7 points. Okay, so let's start with the first point. Now, a way a QR code works is the use of a camera, and you know that sometimes you have menus that are on QR code. So what you have to do is just go to your camera and then scan the QR code, and automatically it will redirect you. So the first thing you can say is that camera captures code. Okay, that's how a QR code works. It uses the camera. Then it says the black squares reflect different light. Okay, it's just same like the barcode. If you know how the barcode works, it's similar, but the difference is the QR code is on matrices, meaning they're squares, and the barcode are lines. Okay, the next one is that the corner squares are for alignment. Okay, they're for alignment. And then finally, now you have to talk about what they're talking about here. We have to explain how that works. So we can say number 4. We've talked a bit about how the QR code works. Now let's see how they will do it. So you can say the pattern is converted to digital data, just the way how the those questions on microprocessors, it's the same thing. It's converted to digital data, then data is sent to microprocessor, data sent to microprocessor. Okay, 6th point, you can now say that data compares with preset value. And number 7, last point, you can say if data is matched, then count is incremented. If data matched, count is incremented. So that will get you your 7 marks easily. Now it's telling us the TLS protocol is used to secure the transmission of data over the internet. Identify 2 layers of the TLS. So we have the handshake layer, and sometimes in exams they can also tell you to explain what the handshake layers are, so you need to understand that. And also they can ask you what is the record layer or how it is used. Sometimes they carry 4 marks just explaining how they work. So here we have the simplest, most easiest question. You just have to fill in the blanks, and it's more usually direct. So the browser requests the web server, okay, so to identify itself by providing its certificate. This is sent and a check is performed to see if it is authentic. You can see I'm not even looking at the options, but I'm sure there must be this, right? Authentic, yeah. If it is the browser, okay, if it is the browser then sends a signal to show that the connection was successful and your data can be transferred safely. It says identify one other protocol that can be used to secure data over the internet. You can say SSL, and we have also learned about SSL. It's basically certificates and authenticity. It's almost as similar as TLS, but this is SSL. You need to understand how SSL also works. So here we have a logic statement, and we are supposed to draw from this logic statement. So let's start. So first, as you can see, you start from here, A NAND B. Okay, that means we join A. Okay, we're joining A NAND B. So we're joining NAND B. Okay, and this therefore is joined by B NOR C. So B NOR, okay, and is joined by not this, so you should have a not here, and now it's finally joined by the OR gate. Sorry for the bad diagram, but in your exam you draw it carefully. That will give you 4 marks for each of the 4 logic gates. It's telling us to complete the truth table for the given logic statement. So what I usually do, number them 1, 2, 3, 4. Okay, so just reduce this. So 1, 2, 3, 4. So you write here 1, 2, 3, and 4. Okay, so let's start with 1. 1 is basically NAND of AB. For any NAND type of gates, you first do the AND and then you just convert it. So here will be 0, 0, 0, 0, 0, 0, 1, 1. This is for AND gate. So for NAND it will be the opposite, to be like this. Okay, and then 2 is basically the B nor C. So we first find for OR gate of B and C. OR gate of B and C is just addition. So basically I'm just adding it. So NOR will be the opposite. So it will be 1, 0. Okay. Then 3 is not 1. So meaning the opposite of 1, which is this. And then finally 4 is basically 3 and 2. OR. So we have to add a 3 and 2. So that will be 1, 0, 0, 0, 1, 0, 1, 1. So that will be the answer to the question. Okay, so that is that. Let's move on now. Quite simple questions. It says the logic statement has 4 different logic gates. Identify 2 other logic gates and complete the truth table. So it has 4 different logic gates. And I know there's the AND gate left. So we have the AND gate. Okay, we have the AND gate and the truth table is just multiplying, so it'll be like this. And then we have the OR gate, or the XOR gate. Actually, you can say any of them. Actually, we already have the OR gate, sorry. So we have the OR gate, right? So we have the XOR gate left. Like is 0, unlike is 1. As simple as that. The next question is telling us Luke is creating a website for his t-shirt design business. He is using HTML to create the website. HTML can be separated into structure and into a presentation. Give 2 examples of a HTML structure. So whenever we're talking about structure, we can say margins, and we can say text, alignment. So anything related to structure will give you something correct. 2 examples of HTML presentation will be the font size, you can say. You can also say font color. Anything related to that, but these are the usual standard ones they give you. Luke is concerned that his web server may be hacked or be subjected to a denial of service attack. State 2 security methods that Luke could use to help protect the web server for hacking or a DOS attack. So what is method 1? Method 1, you can use a firewall. For any DOS attacks, you can use a firewall and you can use a proxy server. Okay, number 6, it's telling us about the von Neumann model. And it's telling us that it contains several integrated circuits. The parallel data transmission is used in an IC, meaning in the integrated circuits. It's telling us, describe how data is transmitted using parallel data transmission. Okay, so parallel data transmission is basically data sent over several bits. Okay, data sent over several data sent, so you can say several bits of data sent over several / multiple wires. Give one benefit of using parallel. So parallel is very fast, so you can just say that fast transmission speed. Then it tells us the computer has a central processing unit, CPU. Identify the bus that carries signals around the CPU to control the components. So we have that's the control bus. that is the control bus. Then identify the register built, that's the accumulator. Simply, this one you just have to remember. You can't, there's no any technique for that. This is the ALU. Says 4 statements about a von Neumann model for a computer system are shown. Tick to show if each statement is true or false. So data and instructions are stored in the same memory unit. That's true. The control unit manages operations within the CPU, that's true. Data and instructions can be fetched into the CPU at the same time. No, not at the same time. It's basically a cycle. This control unit is responsible for decoding an instruction. Yeah, that's correct. The CU. Here now we have a question talking about the MIDI and MP3 format. Okay, so basically an MIDI is just a musical instrument digital interface. That will give you 1 mark, and you can just say does not store actual sound. Then we have the MP3, form of audio, and you can say stores actual recording of sound. So that'll give you your 4 marks. What is LED technology? Light emitting diode. That will give you 1 mark. Then you can say the display is made of pixels. So this is just like a TV. Your TV can be LED. And you can also say the screen can be backlit. So sometimes they can tell you the difference between LED and LCD, so you need to understand that too. 3 benefits of LED. 3 benefits of the LED: it's long lasting, like your TVs. It no flickering, like it's not like the older TVs. And you can also say it has high resolution. But nowadays we also have QLED and OLED and different types of technologies. So another technology is LCD. Now, because computer science is a bit of older syllabus, you cannot write QLED and OLED, so the only option you have is to write LCD. So that's the more safer option. Just write LCD. Okay, parity bit questions. Easiest. It's saying, I don't even need to read the rest. It's saying an even party. So if it's an even party, the number of bits should be even. So here it should be 1 to make, it should be 0 to make it it should be 1 because it's even. Here is 0, here is 0, 0. So I'm basically just adding the ones and it should be even. Identify 2 other error checking methods that could be used to check the binary values that are correct after transmission. You can say checksum, you can say ARQ. Describe how a check digit, how check digit can be used. So check digits. Okay, check digits are basically data is inputted with check digit. Okay, calculation performed on input data, calculated digit compares stored value, and finally, if matches, data is correctly entered.